everyone, welcome back. Module 3, yippee. So the learning targets for 3.1 are going to be, we're going to identify explanatory and response variables. We're going to construct scatter plots. We're going to interpret scatter plots, measure linear association using correlation, and interpret correlation. This is a fun chapter. All right, explanatory and response variables. So most statistical studies examine data on more than one variable. In many of these settings, the two variables play different roles. Response variable measures the outcome of a study, and the explanatory variable may help explain or influence changes in a response variable. So how do you know which is the dependent and which is the independent? So this is how I remember it. You ready? Explanatory. So the explanatory is the X, okay? And that is your independent variable. The response variable then has to be your Y. So just remember, explanatory is your X. Oops, I just put R. All right, and the response variable is your Y. All right? Displaying relationships in scatter plots. The scatter plots can show a relationship between two, you ready? This is really important. They have to be quantitative variables. Remember that from Module 1? So they have to be countable variables, okay, measurable. Otherwise, you're not going to be able to make a scatter plot. You cannot use categorical. Cannot use categorical. All right, the values of the explanatory variable are on the horizontal axis because the explanatory is the X, and the values of the response variable are on the vertical axis or the Y. Each data appears as a point on the graph. So again, remember, explanatory goes on the X. Label, label, label. Okay, label everything and plot your points. All right, displaying relationships, scatter plots. Make a scatter plot of the relationship between body weight and pack weight, so the backpack. Since body weight is our explanatory variable, and we're going to put it on the x-axis. Now I know it didn't tell us here, so they'd have to give us some information, so they're just saying this is your x, this is your y, all right? So we're going to put body weight on the x-axis. And I'm going to put backpack weight on the y-axis. And here I kind of started with the little breaks in the graph, okay? And then you're going to plot the points. So at 120, you're going to go up to 26. At 187, you'll go up to 30. At 109, up to 26, 103 to 24, etc. So that is a scatter plot for this, these two quantitative variables. You can make scatter plots on your calculator. So you could go, let's do it on this one, put in your x variable into list 1, and put list 2 with your y's. Make sure the rest is cleared before you want to do that. So go do that. Go put list 1 and list 2. So if you forget how to do that, you can go to Stat, Edit, and then enter your data. And again, make sure your lists are cleared out first. So you can hit Clear, Enter on the top. Okay, once you have that, you're going to go to your stat plot. So it's second y equals, which is stat plot. And you want to go to the one, let me keep moving forward. I think it got cut off. You want to go to the one that has the one with the scatter plot highlighted. Okay? So highlight and put that one. Make sure you have list 1 and list 2. And then when you go to look at your values on your graph, make sure you zoom stat. So zoom 9. If you see any other funky things going on, it's probably because you had other things in your y equals or other plots on. So make sure you go turn off your y or clear out your y equals and turn off any other plots. So here you can see all of your data. You can hit the trace button and move left and right to see those different data values. So pretty cool. Okay, so interpreting scatter plots. When you're interpreting, you want to always comment on the direction, the form, the strength, and if there's any outliers. So direction. Direction here, you could decrease, you could increase. Okay. Here, this is a no correlation. There's nothing going on. Here, this direction would be a negative quadratic. The form, you could have linear, quadratic, cubic, exponential, power, all of that. So here I can say the direction would be a positive and a quadratic for this guy. So direction is positive, and the shape or the form, we'll say form, doesn't matter, the form would be quadratic. Over here, your direction would be positive or increasing, and your form would be linear. Now the strength is how well the data fits the curve or the line, whichever is appropriate. You could have strong, moderately strong, weak, or no correlation usually as your descriptors. So how are you going to know how strong something is? So let's say this was my data. And I found my line of best fit. Here I can say, well, it looks like the data is fairly close to it, so I could say there might be a moderately strong, okay, here, positive or increasing linear relationship between body weight and backpack weight. All right. And then just an overall statement, the interpretation and context, is that it appears that the lighter students are carrying lighter backpacks and the heavier students are carrying heavier backpacks. So that's a positive association. Okay. Maybe if I can advance this slide. All right, so let's describe the scatter plot. What do you think? This looks what? Well, I would say this would be a weak, negative, linear correlation between final exam grade and absences. So it appears that the higher the grade, the less absences. I wouldn't say mildly strong. I'd say moderate to weak. Sorry. You can ignore that other one. The other thing you could also talk about are your possible outliers. So here it looks like this guy could be an outlier. If I moved that from all the data, then it could definitely shift my correlation and what it would look like. Okay. So variables could have a positive association or a negative association. So let's look at this one. Consider the SAT example and interpret the scatter plot. So what do you think? If I kind of wanted to draw a curve or a line, it would look something like that. So in this case, it looks like there's a fairly moderate, I don't know if I'd go with really strong, but a moderate negative curved relationship between the percent of students in a state who take the SAT and the mean SAT math score. And then you can see that it really looks like there were two distinct clusters. This is something you could comment on as well, of states and two possible outliers that fall outside the overall pattern. So my outliers, it looks like, are this guy and this guy. All right, see how you do on this one. I would say this is pretty strong. It's quadratic. It's negative, curved down. And there doesn't appear to really be any outliers. All right, correlation, we can actually find a better way to say what the correlation is other than just guessing by looking at what's going on. So here I could always find the R squared or R value. With linear, we could just look at the R. If it's nonlinear, we're going to have to look at the R squared. So on your calculators, if you don't mind for me right now, go to the catalog. Log. All right, and scroll down. You could hit the D button, okay, and scroll down to diagnostics. And turn them on. Let me find it on mine really quick. So I'm going to hit the D button, scroll down a few, and you have diagnostic on. Yep, just like that. Okay, so hit enter, and it will say done on your home screen. This is going to make sure that your R values are going to show up in what we're going to do. Okay, so R is a number between -1 and 1. If R is greater than 0, it's telling me there's a positive association, linear association. If R is less than 0, it's saying that there's a negative linear association. If your R value is close to 0, it's saying it's very, very weak linear association. So you want something closer to 1 or -1. If it is 1 exactly, it means that your points lie on an exact straight line. They will all hit on the line. Okay, or that'd be -1 because you're going down. So this would be R is -1. Or an exact line going up would give me an R of 1. So that's a perfect linear relationship. So the closer to 1 or -1, the stronger the strength. All right, so here you could just kind of see, I went ahead and found the R values and of the points going on if I was to do a linear association only. So the first one is basically 0. The next one would be a negative. It's pretty spread out. It was about a 0.3. This next one gets closer together. It's about a 0.5. The next one, you can see it's closer together, but it's negative 0.7. And you can see as you continue, you're getting closer to either 1 or -1. What's going on here? All right, so match the R with the graph. See how you do. And this is what they should be. How did you do? Okay, so this one is negative. It's the only negative, and it's fairly strong. So it's definitely going to go here. Out of the remaining, this one would be the strongest positive. So this guy would have to go here because it's the strongest. It's the closest to 1. And from these two, this one would be stronger. This guy would be stronger than this guy. So the very weakest would go over here. That means that this is left for that one. Okay, how correlation behaves is more important than the details of the formula. If you want to know the formula for R, it's on your formula sheet, but we're always just going to find it in our calculator. Okay. Correlation makes no distinction between explanatory and response. Correlation does not change when the units of measure change. Does not change when the units change. Okay? This actually has no units of measure. Okay, So just to recall, if you're going to do a scatter plot and find the R in the association, both things have to be quantitative. And correlation can be strongly affected by outliers. All right. Which one do you think this would be for R? 0.6, 0.2, negative 0.1, or 0.9? I would say that last one, sorry, would have been 0.9. It's fairly, very strong. What about this guy? I'll let you kind of decide. Sorry. What about that one? And I'm going to give you another one. What do you think D is? So if you had to match all of those, let's see how you would do. Well, D definitely is the only one that could be a negative, so that would be negative 0.1. B was stronger than C, so B would be the 0.6 and C would be the 0.2. Yay! 3.1 summary. A scatter plot displays the relationship between two, again, quantitative variables. Explanatory is the X and may help explain, predict, or cause changes in the response variable, the Y. Oh, I did R again. Okay, when examining a scatter plot, look for an overall pattern showing the direction, form, and strength of the relationship, and look for outliers or other departures from the pattern. And the correlation R measures the strength and direction of the linear relationship between two quantitative variables. And we're going to be finding R more in detail in this next section 3.2. All right, I'll see you then.